Greetings everyone, my name is Stefan Sorger. I'm an instructor for data analytics and other courses. In this tutorial on data visualization, I'll be taking you through 5 essential charts. We've made every effort to ensure accuracy and relevancy of the content. Nevertheless, we cannot control how the information is being used, so we assume no liability for the use of this information. In this presentation, I'll take you through some basic data visualization options in R, including line charts, bar charts, scatter charts, histograms, and box plots. To start, we introduced 2 data sets which we created earlier. The first is a data set on certain house characteristics or house facts of homes found in the 94028 zip code area of the Northern California Bay Area. The slide shows the layout where each row shows records and each column shows variables. The top row is the header row with descriptions of variables. In this slide, we define the variables. The variables in the dataset include price 1,000, which is the sales price of the house times $1,000, size square foot, the size of the house in square feet, lot acre, the size of the building lot in acres, year, the date of construction, bedrooms, the number of bedrooms, and bathrooms, the number of bathrooms. We also include a categorical variable called neighborhood. We need to code the categorical variable using dummy variables. We create 3 dummy variables, one each for each state of the categorical variable called neighborhood. Each dummy variable will be assigned either 0 or 1, depending if the home is located in that neighborhood. But if we have 3 states or conditions, and we know the conditions of the first 2 states, we also know the third, so the third variable is redundant, so we remove it. We also include a second data set, a time series data set called price history, which shows the price over time, in this case from the years 2000 through 2018. We save both the files in comma separated value or CSV format so we can read them into R. We start with line charts. Line charts are good for observing trends. We demonstrate line charts by building a line chart which shows how price has changed over time. Step 1 is to load the data into R. We do so by setting the working directory and then reading our price history CSV file into R using the read.csv function. We verify we've read the data into R correctly by gathering the summary statistics using the summary function. In this case, we can see that the data appears to have been read incorrectly. For example, the year variable shows a min of 2000 and a max of 2018, which agrees with our raw data. We need to tell R what each variable means, so we assign the year data in our data set to a variable called year, and the price 1000 data to a variable called price. We then ask R to print out each one to verify that they are correct. Examining the output, they appear to be reasonable values. We then plot the data using the plot function. The syntax of the plot function is shown on the slide, and we can see we have several variables. We have x and y, which are the data sets for x and y. Type L, which stands for line. Main equals title, which gives us a place to assign the title for the plot, as well as xlab and ylab, which give us a place to assign the titles for the x and y axes, respectively. The resulting plot opens in a new window. We can see that prices have generally increased over time, despite turbulence during the recession of 2008 through 2013. We move on now to bar charts. Bar charts are useful for comparing values of one statistic. Bar charts are popular and are sometimes known as bar plots. We start the bar chart process by reading in the data. In this case, we want to build a bar chart to compare the mean or average prices with the number of bedrooms. To do so, we'll read in the house facts data, which includes data on price and bedrooms. We then ask R to print out the real data frame to verify it was read in correctly. Our data set does not include mean or average values, so we need to compute them. We could manually sort the dataset into groups, one for each number of bedrooms, such as houses with 1 bedroom, houses with 2 bedrooms, houses with 3 bedrooms, and then calculate the mean value of price for each, but that's a lot of work. So instead we use R's aggregate function. The aggregate function asks for the variable for which you want a function to be applied, in this case the price 1000 variable in the real.df data frame. The aggregate function then asks for the variable for which you want the data grouped using the by equals list argument. In this case, we want the data grouped by bedroom, so we tell R to look at the bedrooms variable in the realdata.df data frame. We end the aggregate statement by telling it what function, or fun, to perform. In this case, we want to take the mean of the data, so we say mean. We apply the aggregate function and assign the results to a variable we call chart data. You can see that chart data is a matrix with 2 columns. The column on the left shows different numbers of bedrooms, 2, 3, 4, 5, and 6. The column on the right shows mean prices corresponding to each number of bedrooms. To make the data more understandable, we assign names to the columns using the name function. In this case, we assign the name bedrooms to the left column and the name mean price to the right column. We then invoke the bar plot function to give us a bar plot as shown. The bar plot function asks us what data we want to plot, namely the mean price found in the chart data, the categories for the bar chart, in this case bedrooms, and the labels we should put on the X and Y axes. This slide shows an enlargement of the bar chart. We can see that 5-bedroom houses command the highest prices. Scatter plots are useful for data exploration to discover possible relationships. For example, we could build a scatter plot to test the relationship, if any, between the size of the house and the size of the building lot. We start by reading in the house facts dataset and verify that it was read in correctly. We then need to tell R the variables we want to plot. In this case, we want to plot house size and lot size. So we assign the lot acre data from the realdata.df data frame to a variable we call lot. And we assign the size square feet data from the realdata.df data frame to a variable we call house. We print each variable out to verify that they appear to be correct. We invoke the plot function to plot the data. The plot function asks for X and Y data, the top plot, the color of the plot, as well as the titles for the overall plot, the x-axis, and the y-axis. In our case, we want a scatter plot, which is the default, so we do not need to include a type. Our resulting function is then plotted as a function of our lot variable, which includes the size of the lot, our house variable, which includes the size of the house, our main title, which is house size versus lot size, and the titles for the X and Y axis, which are lot size and house size, respectively. This slide shows an enlargement of the scatter plot. We can see a cluster of data in the lower left corner, along with outliers on the top and right side. Histograms are useful for identifying frequent values in general and seeing segments and outliers in particular. In our case, we will build a histogram of house prices to test if we can identify different groups. We start by reading in our house facts data and verifying it. We then plot out the data using the histogram function. The R help file for the histogram function tells us that the syntax starts with the word hist, followed by multiple arguments in parentheses. The arguments include the data we wish to plot, in this case price, along with color, the title of the chart, and the title for the x-axis. This slide shows an enlargement of the histogram. We can see at least 3 groupings, one centered at about 2.5 or 3 million, one centered at about 12 million, and one centered at about 18 million. If we had wanted more granularity in the histogram, we could ask R to provide that to us using the breaks argument in hist. Our final data visualization for this video will be box plots. Box plots allow us to understand the range of data associated with different conditions. For example, We'll build box plots of average or mean prices for different numbers of bedrooms. We start by reading in the house facts data and verifying it. We then invoke the boxplot function. The R help file for the boxplot function tells us that the syntax starts with the word boxplot, followed by multiple arguments in parentheses. The first argument, form, is the formula R should use to calculate the boxplot, where we take X, representing a vector of data values, and split it into groups using the variable grp, or group. In our case, we want to split the price 1000 variable in our realdata.df data frame into groups, each corresponding to a certain number of bedrooms. The remainder of the arguments allow us to specify the title for the chart as well as the titles for the X and Y axes. This slide shows an enlargement of the box plot. We can see very little variation in homes with 2 or 6 bedrooms, probably because they are fairly rare. We can see quite a bit more variation in the other bedroom groups, especially with bedroom 5, which includes several outlying values. In this video, we covered 5 popular types of data visualization techniques, including line charts, bar charts, scatter charts, histograms, and box plots. Thank you for watching. If you found this video helpful, please subscribe to the channel.